The cat sitting in your home right now is the result of 30 million years of evolution. That's not a metaphor or an exaggeration. The body plan it uses to jump onto your kitchen counter, the eyes it uses to stare at you at 3 a.m., the reflexes that make it impossible to sneak up on, all of that was built and refined over 30 million years of living and dying in some of the harshest environments on Earth. The animal sitting there asking for breakfast descended from creatures that shared the planet with animals we'd find terrifying. It survived mass migrations, climate shifts, and the extinction of dozens of its relatives. And somehow, at the end of all that, it ended up on a couch. This is the story of how that happened. The story starts about 30 million years ago in Europe, with a small animal that looked surprisingly like a cat. Not exactly like a cat, but close enough that if you saw one running through a forest today, you'd probably say it was some kind of cat. It was roughly the size of a large house cat, maybe a bit longer in the body, and it loved climbing trees. What matters is what it was doing. It was hunting, climbing, and surviving in a competitive world. And it was doing it well enough to stick around for 6 million years without changing much. When a design works, evolution doesn't rush to change it. The interesting thing about this first cat is how complete the design already was. It had the same basic body plan that modern cats use today. Flexible spine for explosive acceleration, forward-facing eyes for judging distances, retractable claws for climbing and gripping, and teeth designed for killing rather than chewing. Evolution had essentially solved the problem of how to be a small predator, and it solved it so well in this early animal that the basic answer hasn't changed in 30 million years. Every cat alive today, from the tiger to the sand cat to your house cat, is running on the same fundamental hardware that this early animal was running on. The software has been updated considerably. The hardware is largely the same. About 20 million years ago, a new group appeared that changed everything. These animals were bigger, more varied in size, and they spread further, moving from Europe into Asia and eventually into North America, across the land bridges that existed back then. The smallest of them were the size of a large house cat. The biggest were closer to a small leopard. This group is important because it's the one that eventually split into every cat alive today. Every single cat that exists now traces back to this group. The basic cat blueprint, flexible enough to eventually produce animals as different as a cheetah and a snow leopard, was established here. Around 10 million years ago, the cat family divided into two main branches. One branch would eventually produce the big cats, lions, tigers, leopards, jaguars, and their relatives. The other branch would produce everything else, including the wild cats that became your house cat. The simplest way to tell them apart today is not actually size, because some so-called small cats are heavier than some big cats. The real difference is a small piece of bone in the throat. Big cats have a flexible version that allows them to roar. Small cats have a rigid version that allows them to purr continuously, both when breathing in and breathing out. 10 million years of separation, dozens of species, and the dividing line comes down to whether the animal roars or purrs. Nature has a sense of humor. The 10 million year separation between the two branches produced animals that look dramatically different on the outside, but are built from almost identical blueprints underneath. A tiger and a domestic cat have nearly the same bone structure, the same organ layout, the same hunting instincts. Scale the tiger down to house cat size, and the behavioral differences become surprisingly small. Both stalk prey the same way. Both use the same killing technique. Both knead with their paws as kittens, and sometimes carry that behavior into adulthood. The two branches diverged 10 million years ago and went in different directions, but they never wandered so far that you couldn't see the family resemblance. While all of this was happening, another group of cats was running a completely different experiment. The saber-tooths. These were not the ancestors of modern cats. They were a separate branch that evolved alongside the ancestors of modern cats for millions of years, and in some ways, outcompeted them. At their peak, saber-toothed cats lived on every continent except Australia and Antarctica. Some species were relatively small. Others weighed 400 kilograms and had canine teeth over 20 centimeters long. They were genuinely terrifying animals, and they were successful for an almost incomprehensible length of time. The saber-tooth lineage lasted over 20 million years. By the time they went extinct, about 10,000 years ago, the ancestors of your house cat had already been cats for millions of years. The two lineages ran in parallel, and then one of them simply disappeared. Nobody knows exactly why the saber-tooths went extinct. The timing lines up with both major climate changes and the spread of early humans across continents, and the honest answer is probably that both played a role. What's interesting is that 10,000 years ago, when saber-tooths went extinct, is also roughly when cat domestication began. Whether that's a coincidence is a question that doesn't have a clean answer. What we know is that the saber-tooths, after 20 million years on Earth, are gone. And the small wildcat from the Middle East that people started keeping around their grain stores is now found on every continent on Earth. Evolution doesn't always reward the most impressive design. What the saber-tooths left behind was an open ecological niche. For millions of years, they had been the large ambush predators, the animals that took down prey too big for other cats to handle. When they disappeared, that role didn't stay empty for long. Lions and tigers expanded to fill some of it. But the real winner of the saber-tooth extinction wasn't any particular predator. It was the small wildcats that had been living in the margins, keeping out of the saber-tooth's way, hunting smaller prey, staying flexible. Those animals were still there when the saber-tooths were gone, and they were still there when the world changed again. The big cat branch gave the world some of the most impressive predators that have ever existed. The tiger is the largest cat alive today, and it hunts through dense vegetation using a combination of patience and explosive speed that makes it one of the most effective ambush predators ever evolved. The lion went in a completely different direction and became the only truly social cat, hunting in groups and raising cubs communally in a way no other cat does. The leopard became the most adaptable big cat, living everywhere from rainforests to deserts, dragging prey heavier than itself up into trees to keep it away from scavengers. The jaguar developed the most powerful bite of any cat, strong enough to go straight through a skull or a turtle shell. Each of these animals is a different solution to the same problem. How do you catch and kill large prey without being killed yourself? The big cats answered that question 4 different ways, and all 4 of them worked. The big cats also tell a story about how dramatically ranges can shrink. Lions once lived across Africa, Southern Europe, the Middle East, and into India. They're now found only in sub-Saharan Africa and a single small population in Western India. Tigers once ranged from Turkey to the Russian Far East and down through Southeast Asia. Their current range is a fraction of what it was 200 years ago. The cheetah, which once lived across Africa, the Middle East, and into India, now survives in scattered populations. The big cats are ancient, successful, and increasingly squeezed into corners of the world that humans haven't fully taken over yet. The small cat branch was quieter about it, but no less successful. Over millions of years, small cats spread across Africa, Asia, Europe, and the Americas, filling roles that the big cats either couldn't or didn't. Some became specialists. The fishing cat of South Asia wades into water and catches fish with its paws. The sand cat lives in deserts so hot that the ground temperature would burn unprotected skin, and can go weeks without drinking water. The Pallas's cat of Central Asia has the densest fur of any cat on Earth and looks permanently annoyed, possibly because it has been living in cold, rocky terrain for millions of years and has had enough of it. The small cat branch produced about 33 species, each one a slightly different version of the same basic design, each one working in a different corner of the world. The small cats also solved a problem that the big cats never fully solved: how to live almost anywhere. A lion needs open savanna, A tiger needs dense forest with enough large prey to sustain its body weight. Each big cat is a specialist, built for a specific environment. The small cats were generalists. The wildcat group that eventually produced domestic cats could live in forests, deserts, scrublands, wetlands, and agricultural land. It wasn't the most impressive predator in any of those environments, but it could survive in all of them. That flexibility, built into the small cat branch over millions of years of adapting to different landscapes, turned out to be the most valuable trait any cat ever evolved. One small cat branch made a decision that no other cat made. It traded almost everything for pure speed. The cheetah gave up the ability to fully retract its claws, gave up heavy muscle mass, gave up the ability to roar, and in exchange, got a body that can reach 100 kilometers per hour in about 3 seconds. No land animal on Earth accelerates faster. The trade-off is that a cheetah can only hold that speed for about 30 seconds before it overheats and has to stop. It also can't fight off lions or hyenas that want to steal its kill, because its lightweight body isn't built for that. The cheetah made a very specific bet, that being the fastest thing alive was worth giving up almost everything else. For millions of years, that bet paid off. Among all the wildcats scattered across Africa, Asia, and Europe, one population made a choice that none of the others made. Or rather, they didn't make a choice so much as they started showing up near human settlements in the Middle East about 10,000 years ago, when humans first began farming grain. The wildcat in question was a small striped animal living across the Fertile Crescent, and it was drawn to grain stores not because it ate grain, but because the grain attracted rodents, and the wildcat ate rodents. The farmers noticed these cats were killing the mice that were eating their food supply. The cats noticed that living near humans provided a reliable and dense concentration of prey. Neither side sat down and negotiated. They just both kept showing up, and gradually something that looked like a partnership emerged, without anyone planning it. The standard story says humans domesticated cats. The actual story is more complicated. Cats are the only domestic animal that domesticated itself to a significant degree. Dogs were deliberately bred over thousands of years, selected for specific traits, pushed towards specific behaviors. Cats came to humans on their own terms and changed much less in the process. The genetic difference between a domestic cat and the wild cat it descended from is smaller than the genetic difference between a domestic dog and a wolf. Cats kept most of their wild instincts, their solitary hunting behavior, their territorial nature, their indifference to commands. What they lost, over thousands of years living near humans, was primarily the fear response. They became animals that could tolerate human presence without stress. The meow is a good example of how this relationship shaped the cat. Adult wildcats don't meow at each other. They use meows rarely, and mostly with kittens. The meow that domestic cats use constantly with humans is a behavior that developed specifically for communicating with people. The pitch of a domestic cat's meow is remarkably close to the cry of a human infant, and researchers think this is not a coincidence. Cats that produced sounds closer to a human baby cry were more likely to get a response, more likely to get fed. Over generations, cats living near humans developed a communication system tuned specifically to get a reaction from people. The wild cat in the forest doesn't meow at you. The cat in your kitchen does. That difference is 10,000 years of a cat slowly learning how to talk to humans. Not because anyone taught it, but because the cats that were better at it survived. Every other cat species alive today has a limited range. Some are found only on one island. Some survive in a single mountain range. The domestic cat is found on every continent except Antarctica, in every climate from Arctic to equatorial, in cities, forests, deserts, on ships, on islands that no other land predator ever reached. There are somewhere between 600 million and 1 billion domestic cats on Earth. No wild cat comes close to those numbers. The wildcat that started wandering near grain stores 10,000 years ago has, by any reasonable measure, conquered the planet. It didn't do it by being the biggest, or the fastest, or the strongest. It did it by being exactly flexible enough to live alongside the one species that ended up controlling most of the Earth's surface. 30 million years of evolution, dozens of extinct relatives, the rise and fall of the saber-tooths, and the end result is an animal that has taken over the internet, lives in more homes than any other pet, and still, occasionally, at 3 in the morning, reminds you that it hasn't entirely forgotten what it is. What happened after domestication began is a story of an animal spreading further and faster than any wild predator ever had. When human populations moved, they brought their cats. Ships crossing oceans carried cats to keep rodents out of food stores, and those cats arrived on islands that had never had any land predator before. Human settlements in new territories brought cats that immediately established themselves as the dominant small predator. The domestic cat moved with humans from the Middle East to Egypt, from Egypt across the Mediterranean, from Europe to the Americas, from trading ports across Asia. Every time humans went somewhere new and built something worth protecting from rodents, cats followed. There is something almost absurd about the endpoint of this story. The saber-tooth cat, 400 kilograms of muscle and fang, is gone. The cave lion, the largest cat that ever lived, is gone. Dozens of species that were faster, stronger, or more specialized than the wild cat from the Fertile Crescent are gone. And the animal that survived all of them is the one that figured out how to be useful to humans. Not the most impressive predator, not the biggest or the most fearsome. The one that showed up near the grain store, stayed calm when a person walked by, and kept coming back. 30 million years of evolution, and the winning move turned out to be, just don't run away.